Today's lesson is on segment and angle bisectors, and I think a good essential question for this lesson would be, what are segment and angle bisectors? And how can I use what I know about them to calculate segment lengths and angle measures? So here we go with our vocabulary. What is the point that divides or bisects a segment into two congruent segments? That would be, and I'm going to abbreviate segment here, a segment bisector. You can't just say bisector because there's also an angle bisector, obviously. So I have to designate that I'm speaking of a segment bisector. What do I mean to divide? And that should just be and. To divide an angle or segment into two equal parts would be to bisect that segment or angle. A segment ray line or plane that intersects a segment at its midpoint. Oh, you know what? That's actually a segment bisector. This first one, the point that divides, that's actually the midpoint. Let me go back and fix that. Everybody fix that in your notes. That is the midpoint of the segment. The segment's midpoint is the point that divides or bisects the segment into two congruent segments. What is the construction tool that's used to draw arcs? We don't use a protractor for that. We use a compass to draw arcs. The tool that we use to draw segments, yeah, it's a ruler, but we're not going to use a ruler that actually has the measurements on it. We're going to use just a straight edge. Straight edge makes segments. To draw using a limited set of tools, typically compass and straight edge. Every once in a while we'll need a protractor for a construction, but most often we will just use our compass and straight edge to make those drawings. Sorry. To draw is just to construct. It's the drawing itself that is the construction. Sorry, I'm getting ahead of myself. So to draw is to construct, the drawing is the construction. Formula used to find the midpoint of a segment, well, that would be the midpoint formula. And I'm going to jot that down over here. We use a capital M. Remember, little m is for slope. Capital M is the first x coordinate plus the second divided by 2, and the first y coordinate plus the second divided by 2. There's your midpoint formula. You will need to remember that. A ray that divides an angle into two adjacent angles that are congruent would be an angle bisector. And this reminds me that I accidentally forgot to fill in one of your terms on last night's notes. It said a pair of angles that share a common side. I forget what it was, but anyway, the definition I should have written was adjacent angles. Here's a pair of adjacent angles. Okay, those, so if this is A, B, C, D, angles ABC and angles CBD are adjacent angles because they share this ray BC, they share a side. Okay, so those are adjacent angles. If you didn't get that filled in last night, I know I just realized after I posted the video that I had left it out. These are adjacent angles. They share a side. They share a ray that makes a side of both angles. An array that divides an angle into two adjacent angles that are congruent. So if this is A, B, C, and if I have a ray here, let's call that point D. If ray BD is an angle bisector, then that means that angle ABC is congruent to angle DBC. So if I have that drawing there, based on these markings, I know that ray BD is an angle bisector. If point A has coordinates x sub 1, y sub 1, and point B has coordinates x sub 2, y sub 2, and these are points in the coordinate plane, then the midpoint of AB has coordinates. Well, remember, we want to use our midpoint formula. So I just wrote it up there for you a minute ago. We'll write it again here. x1 plus x2 divided by 2. And y sub 1 plus y sub 2 divided by 2. Remember, guys, this might help you when you're thinking of midpoint. Think you're trying to find the average of the 2 points. So if you got AB here, and here's B, y sub 1, y sub 2, and you're trying to find this midpoint here. See, if you add, I'm sorry, this should be x sub 2 here. So if I'm trying to find the x-coordinate of our midpoint, then it's the average. It's the average, right? Right in the middle. So what am I going to do? I'm going to add x sub 1. I'm going to add to that. I'm going to add x sub 1 and x sub 2 and divide it by 2, and I would do the same for the y-coordinate. So if you have a little trouble remembering the midpoint formula, try remembering that the midpoint is just the average of the other 2 points. So let's do an example with actual numbers here. I want the midpoint of AB, so I'm going to take x sub 1, which is -3, add to that x sub 2, divide that by 2. My y-coordinates would be -4 plus 5, and then I divide that by 2. So what does that give me? 2 over 2, which is 1, and -4 plus 5 is 1 over 2. So there's my midpoint of segment AB, 1/2. Ooh, here's a good problem for you. I think it would be a great idea for you to pause the video and try to do this one on your own, and I'll work it while you work it, and you come back and check your answer. I always like to start with the formula. X sub 1 plus x sub 2 over 2, y sub 1 plus y sub 2 over 2, and now I'm going to substitute one endpoint. So, but I know the midpoint. It's 1, 4, and I know one x and one y. So I'm going to have -3 plus the other endpoint over 2, and I'm going to have 2 plus y sub 2 over 2. Take a minute there if you got stumped on this and see what I did. I wrote my formula and then I simply plugged in the information that was given. So what I'm going to do is I'm going to separate out, first of all, I'm going to, well, I didn't want to include the 4 there. I'm going to take this part here and I'm going to solve for x sub 2, and then I'll do the same thing for y sub 2. So let me solve for x sub 2. So what am I going to do? I'm going to say 1 equals -3 plus x sub 2 over 2. How do I solve a proportion like this? Well, I just cross multiply. So 1 times 2, 2 equals -3 plus x sub 2. So x sub 2 is going to end up being 5. Let me now solve for y sub 2. I'll do the same thing I did here for x. My y value is 4. I got that right there, 4. And I know that equals 2 plus y sub 2 over 2. Cross multiply, I get 8 equals 2 plus y sub 2. So y sub 2 then is going to be 6. So the other endpoint, what is the other endpoint? The other endpoint is k, so I know that k is 5, 6. And that is how you would want to express your answer there. We're going to look at angle bisectors now. An angle bisector divides an angle into two congruent angles, each of which has half the measure of the original angle. Here are some examples. EG, so here we go. EG is the bisector of angle DEF. Find the two measures that are not given. Well, based on the definition of an angle bisector, I know that this angle here, angle DEG, has to also be 52 degrees. How do I know? Because they told me EG is the angle bisector. And in this case, if EG is the angle bisector, then I know this, I think that's a 64 degrees. Well, this is not a great picture. So here's what I know. If the measure of angle DEG, let's look at this very closely. If the measure of angle DEG is 64 degrees, then I know that the measure of angle GEF has to also be 64 degrees. But it looks to me like the measure, so let's all write this down so we don't get confused. We're going to assume that 64 degrees is the measure of angle DEF. I might be assuming wrong, but I can tell that the measure of angle DEG is not 64. It's too small. So let's say the measure, the whole thing, let's say the measure of the whole thing is 64 degrees. And then that would tell me that each of these has to be 32 degrees. That's more representative of the picture, so we're going to go with that. Just remember, whatever the measure of angle DEG is, it also has to be the measure of angle GEF. All right, in the diagram, KM, in the diagram, I don't see a diagram. I guess we better find a diagram. We better make one. KM bisects JKL. We'll draw JKL here. JKL. And KM bisects that angle. Find the measures of angle JKM, so that would be that one, and the measure of MKL, that would be that one. Well, I know they're congruent. Okay, I'm a little confused here. I think our diagram is missing. I think in both of these cases our diagrams are missing, so let me just make up a number. Let's say that the measure of angle JKL equals 84 degrees. So find the measures of JKM and MKL. Well, obviously those measures would have to be half of 84. So they would be 42 degrees each. All right, now let's look at angle ABC here. Angle BD. I'm going to pause this so I can make up a good problem for us since our figures are missing, our diagrams are missing. So I'll be right back. Okay, here's the problem I came up with for us. So let's do this together, or you can try to do it on your own. So let's see, BD bisects angle ABC. So what do we know? Let's go ahead and mark it. We know that angle ABD and angle DBC are congruent. So how are we going to find the measures of those angles? Well, what do we know? Oh, they're congruent, so we know that their measures are equal. So x minus 22 equals 2x minus 74. Let's solve for x. So negative 22 plus 74 is going to equal x. That's going to be 52. X is 52. So if we plug x into either one of these, we're going to get the same answer. Why? Because those two angles are congruent. So I know that the measure of angle ABD equals the measure of angle DBC. And remember, I can substitute my 52 into either one of those expressions, so I'm going to do the easiest one, which would be x minus 22. 52 minus 22, which is 30 degrees. So each one of these angles measures 30 degrees. So what does that tell me about the measure of angle ABC? It would have to be 60, right? The measure of angle ABC would be 2 times 30, which is 60 degrees. And clearly you can see from my picture that I actually drew an obtuse angle here. ABC is an obtuse angle based on my drawing. Based on my numbers I made up, it measures 60 degrees. So sometimes when you make up a problem, the diagram doesn't really match what the answer is. You gotta stick with the algebra. You can't say, oh, it doesn't equal 60 just because it looks obtuse. You gotta rely on your algebra. Whatever answer your algebra gave you, that's what you want to go with. One more example, of course, or no, actually two. So you need to do these for yourself. Come back and check after I work them here. So here's what I realized when I paused the recording and was working these problems. These are actually the figures that were supposed to be with the two problems on the previous page. So hey, no harm. We just got two extra examples. So you do these the same way that I did the other two. Set the two angles equal. Why can we, the measures equal, that is. Why can we do that? Because we were told that BD in this case and KM in this case were angle bisectors. In both cases, we solve for x, and then we go back and we plug our x value into either one of the expressions. Why can I plug it into either one? Because I know that the two angles are congruent and therefore their measures are equal. And so in the first case, I get that the measure of each of these angles is 75 degrees. And that would make the measure of angle ABC, what, 75 times 2, which is 150 degrees. And in the next problem, I got that the measure of each angle is 55 degrees, which would make the measure of angle JKL 2 times 55, which is 110 degrees. And those look much nicer than my example I made up because they are both obtuse angles, and when I add those two congruent angles together, I do get measures greater than 90. So be sure to write yourself a summary and look back over your notes. Make sure it all makes sense to you. Jot down any questions you may have to ask me in class tomorrow.